All right, we are starting worksheet 2. So now we're looking at, for the first part, determine whether the curve has a relative maximum, which I like to remind myself that's when R changes from increasing to decreasing, a relative minimum if R changes from decreasing to increasing, or neither, like increasing to increasing or decreasing to decreasing. Justify your answer. Okay, so what we do is still make a table. Whatever interval you're given, I like to give myself a little visual. I've done this before. We're going from negative pi over 2 to pi over 2. I like to give myself a visual of like what are all the angles that I could be plugging in. And even though this seems like a lot of angles, this is our largest interval here. It's a good idea to plug them all in because you don't want to miss a place where R changed from increasing to decreasing just because you skipped over an angle. So plug in all of the common angles, including the endpoints between negative pi over 2 and pi over 2. So we're going into R equals 1 plus 2 cosine theta. What we're looking for is once we get the values of R, is R increasing or decreasing or what's happening for all of these angles. So start with negative pi over 2. 1 plus 2 times the cosine of negative pi over 2 or pi over 2 is 0. So that's 1. And then remember, we're calling this negative pi over 2, so we can call this next angle negative pi over 3. You could make it 5 pi over 3. It really doesn't matter. You're just thinking about the sign, the value, I mean, of cosine here, like is it positive or negative? So 1 plus 2 times cosine's positive 1/2 at the pi over 3. So 1 plus 1 is 2. Negative pi over 4. 1 plus 2 times positive radical 2 over 2. It's going to be 1 plus radical 2. Plug in negative pi over 6. 1 plus 2 times radical 3 over 2. 1 plus radical 3. Plug in 0. 1 plus 2 times 1 is 3. Plug in pi over 6. We're going to get the same values, right? You can use your knowledge of the unit circle a little bit here. Cosine is positive at all of these same values, so it's going to be back to 1 plus radical 3. When I plug in pi over 4, I get 1 plus radical 2. When I plug in pi over 3, I get 2. 1 plus 1, right? And then when I plug in pi over 2, I'm going to be back to what I had before, back to 1. So let's take a look at these values. We go 1, 2. Radical 2 is 1 point something. So this is like 2 point something. So we're still increasing. Radical 3 is 1 point something a little bit higher. So 2 point something a little bit higher. And then 3. And then we start decreasing again. So this is R is increasing on negative pi over 2 to 0. And then from 3 down, it starts going back down. 2 point something, 2 point something, 2, 1. So here, R is decreasing on 0 to pi over 2. I'm using parentheses for everything because these turning points here, like at 0, that's technically where R hits a maximum, right? So it's neither increasing nor decreasing. And I'm just realizing I have to answer this question here. So because we're going from increasing to decreasing, I didn't leave much room for this, but R has a, actually I want to change how I organize this, sorry, just to give myself more room to explain this. So increasing, decreasing, that's just for me. So my answer here, if I had to write this for the AP exam, I would say R has a relative max. We might as well say where at theta equals 0 because R changes from increasing to decreasing. We have a very similar concept in AP Calculus where you have to use basically the same explanation, but we're talking about f of x instead of r. So when you have to justify there's a relative max, you specifically have to say the function is changing from increasing to decreasing. Okay, lighter work here. We're going from pi over 2 to 3 pi over 2. Oh, just kidding. Not lighter work. We have all of these to do still. Okay, so same amount of points to plug in. Now you can kind of get a preview for what's going to be happening though, right? Cosine's negative in both of these quadrants, but we're going to be able to use similar values. So we're still plugging in a 1 plus 2 cosine theta. Start at pi over 2, which you already have an answer for. That's 1. And then you're going to plug in 2 pi over 3. That's going to be 1 plus 2 times negative 1/2. So 1 minus 1 is 0. And then plug in 3 pi over 4. 1 plus 2 times negative radical 2 over 2 is 1 minus radical 2. That's something negative, right? Because this is 1 minus 1 point something, so it'll be like negative 0 point something. And 5 pi over 6, same idea. 1 plus 2 times negative radical 3 over 2. So that'll be 1 minus radical 3. Plug in pi, 1 plus 2 times negative 1. So 1 minus 2 is negative 1. So far we're decreasing from positive 1 to 0, decreases to negative 0 point something, to negative 0 point something, to negative 1. And then remember, just use, I guess, the idea of symmetry, or we're going to be plugging in similar values. When I plug in 7 pi over 6, because cosine's still negative in quadrant 3, I should get the exact same thing I got when I plugged in 5 pi over 6. So save yourself some computation here. 5 pi over 4 is going to be 1 minus radical 2. 4 pi over 3 is going to be 0. And 3 pi over 2 is going to be back to 1. So this time we're going from decreasing. The lowest negative number is negative 1. And then we start going back to negative 0 point something, negative 0 point something, 0, 1. So decreasing and then increasing. If you're decreasing and then increasing, there's a relative minimum. So I'm going to squeeze this in down here. Relative minimum at theta equals pi, because r changes from decreasing to increasing. When we have a test over this section, I will have you justify your answers, and so you'll need to basically use this little, I guess it's kind of a script, but that's the justification. All right, 4 pi over 3 to, did I keep this at 2 pi? Let me just double check. I think I did. Yeah, I did. Okay. Sorry, I just didn't want to do the problem differently. Okay, so from 4 pi over 3 to 2 pi. So I know some of this is cutting into what we already did, but I'm just looking at different intervals here and what's happening. All right, so we've already plugged in 4 pi over 3. That was 0. We've already plugged in 3 pi over 2. That was 1. Notice that the relative max and min so far have happened at these non-quadrant angles here. So let's see if that has any connection here. So 3 pi over 2 is 1, and then we would be plugging in 5 pi over 3. Now 5 pi over 3, we've already done these values, right, in quadrant 4. So let's just use what we've already done here in the negative section. So 5 pi over 3, same as negative pi over 3, should get 2. And then 7 pi over 4, it's the same as negative pi over 4, coterminal anyway, so 1 plus radical 2. And 11 pi over 6, coterminal to negative pi over 6, 1 plus radical 3. And finally, 2 pi should be the same as what I got when I plugged in 0. That was 3. So let's see. These values are increasing, right? 0, 1, 2, 2 point something, 2 point something, 3. So this time r is increasing on the entire interval. So there's no relative, instead of saying max or min, I'm just going to say extremum. That's a singular max or min. On 4 pi over 3 to 2 pi. That's because r is increasing the entire way. Maybe I should say that. R increasing. Okay, let's do this again. This is one of those rose curves, right? So let's look at this section here, smaller sections, pi over 6 to pi over 2. There are only a couple of angles in between there. So same idea. It's just about carefully kind of plugging into these functions and seeing what's happening. So plug in pi over 6. Now, when you plug in pi over 6, you're multiplying it by 3. 3 times pi over 6, 3 pi over 6, is pi over 2. So multiply the angle by 3 and then take the cosine of it. Cosine of pi over 2 is 0. And then we're going to plug in pi over 4. 4 times the cosine of, it's 3 pi over 4. So that's quadrant 2. So that's 4 times negative radical 2 over 2. So negative 2 radical 2. So far I know it's a decrease because 0 to negative. And then pi over 3, that's 4 times the cosine of 3 pi over 3, which is pi, which is negative 4. So I know negative 4 is further down the negative number line than negative 2 radical 2, because this is like negative 2 times 1 point something. So we're still decreasing. And then pi over 2 is 4 times the cosine of 3 pi over 2, which is still 0. So there were probably some other angles that I might want to plug in with the 3 theta, but I'm still just going with my common angles and looking at what's happening here. So we went from decreasing. We know that negative 4 is the lowest r can go because remember that's like the petal length there. So that's definitely a minimum value. And then if I were to plug in some other values, like some values between pi over 3 and pi over 2, I don't have to do that. But if I were, I would get the negative numbers to start climbing back up. So from negative 4 to 0, the graph is increasing. That means that we went from decreasing to increasing. So r has a relative minimum at theta equals pi over 3 because r changes from decreasing to increasing. All right. Pi over 2 to 5 pi over 6. So here's pi over 2. Here's 5 pi over 6. On my original answer key, I'm not sure if I plugged in more angles like the ones that would satisfy 3 theta, but I think we're okay with just doing common angles. That ought to get our picture across. The only time you know you need more angles is if you totally skip over a max or min value. We know what the max and min can be because cosine has a max and min of 1. So the biggest this can be is 4. The smallest is negative 4. This one, the biggest it can be is 3. The smallest is 1 minus 2, negative 1. So if you don't see that max or min value and you're looking for a max or min, you need to plug in some other angles in between values that you have. So we start with pi over 2, which we already plugged in. We got 0. And then we can plug in, 2 pi over 3. Now remember, you're plugging that into 3 theta, so that's 4 cosine of 2 pi, which is 4. So there's an increase to a max value. And then you're going to plug in 3 pi over 4. Now this is 4 cosine of 9 pi over 4. That's bigger than a full circle. That's 2 and a fourth, right? So that would land you in quadrant 1. So that's 4 times positive radical 2 over 2. So it's positive radical 2 over 2. So we're starting to decrease. And then 5 pi over 6 is our last value. That's 4 times the cosine of 3 times 5 pi over 6. So 3 over 6 reduces. So it's 5 pi over 2. And that's back to 0. So r is changing from increasing to decreasing. That means that there's a relative max at theta equals, where does it hit 4? It hits 4 at 2 pi over 3. And that's because r changes from increasing to decreasing. All right, last one of these. So now we're on 5 pi over 6, which is here, to 3 pi over 2. So we're going to plug in all these quadrant 3 angles plus our non-quadrants. All right, so if we plug in 5 pi over 6, we just got on the last table that that was 0. We plug in pi, that's 4 cosine of 3 pi. 3 pi lands at pi. Every odd pi lands in the same position as pi. So that's negative 4. So there's a minimum right there. And then we're going to say 7 pi over 6, which is 4 times the cosine of 3 times 7 pi over 6, so 7 pi over 2, which is back to 0. Every pi over 2 cosine is 0. And then 5 pi over 4. So that's 4 times the cosine of 15 pi over 4. So let's see, what is that? That's 3 and 3/4. So that's kind of confusing. Maybe think about it as this 15 pi over 4. So where would 3 and 3 pi plus another 3/4 pi, where would that fall? So 3 pi is here, and then rotate another 3/4. So 1/4, 2/4, 3/4. That puts you right here in quadrant 4. Cosine's positive over there, so we're back to positive. 4 times radical 2 over 2 is 2 radical 2. 4 pi over 3. 4 times the cosine of 3 times 4 pi over 3 is 4 pi. Back to 4. And then finally, 3 pi over 2. This is why we plug in all the angles. Some interesting things have happened here. So 4 times the cosine of 9 pi over 2 is still going to be 0. So from 5 pi over 6 to pi, the graph decreased and it hit its minimum. And then the graph increases again until you get to 4 pi over 3. But then the graph decreases again. So there are actually two relative extrema here. We're going from decreasing to increasing. So there's a relative min at theta equals pi. And that's because r went from decreasing to increasing. I'm shortening up my writing a little bit. But then there's also, we went from increasing to decreasing. So there's also a relative max at theta equals 4 pi over 3. And that's because r went from increasing to decreasing. All right. Average rate of change. So find the average rate of change of the polar function on each interval. Then use the average rate of change to approximate the function value. So you want to get this formula in your head. Again, we use this a lot in calculus too. Average rate of change from 0 to pi over 6. So on a polar graph, it's hard to visualize what's happening there. If we graphed this in an xy plane, we would just be finding the slope between these 2 points. So anyway, the formula is r of pi over 6 minus r of 0 over pi over 6 minus 0. All right, so what is r of pi over 6? That's 2 plus 2 times the sine of pi over 6, which is 1/2. So 2 plus 1 is 3. And what is r of 0? That's 2 plus 2 times the sine of 0, which is 0. So that's 2. So this is going to be 3 minus 2 over pi over 6. We don't need the minus 0 part. That's 1 over pi over 6. Do not leave this as a complex fraction. That's the same as 1 times 6 over pi. So the average rate of change is 6 over pi. And then, again, another calculus thing we do all the time right in the beginning of the year. Use a rate of change to approximate a function value. So that means we're always going to start at the beginning of our interval. So start at r of 0. Add to that the slope, the rate of change, 6 over pi, times the distance that you're crossing. So you're going from 0 to 5 pi over 12. So it'll always be your second value minus your jumping off point. This is just a little linear equation. We're just saying we know that this graph is curved, but we're just saying like, okay, we know the graph does this. We have this little tangent line, so let's just approximate the value on the tangent line and see if it's close. Okay, so r of 0 is 2. 5 pi over 12 minus 0 is just 5 pi over 12, right? So when you're multiplying these, the pi's cancel. The 6 over 12 becomes 1/2. So it should just be 2 plus 5 over 2. So 2.5. So that's 4.5. So that's an approximation for r of 5 pi over 12. And then we don't have this on our test, but error is another thing that we look at a lot in BC calculus. So how far is this approximation, or how good is this approximation, basically? So use your calculator to find the actual value. I have that in quotes because it's still being rounded on our calculator. So let's just see, we're in radian mode. What is 5 pi over 12 if I plug that in? 2 plus 2 sine of 5 pi over 12. So the actual value, r of 5 pi over 12, is actually, I'm going to write down all the decimals, 3.931, 851, 653. My approximation was about 4.5. All right, so what's the error? How far off are we? I'm just going to subtract these two. So I'm just going to say minus 4.5. The order of subtraction doesn't really matter. When we do this in calculus, we put an absolute value around it to say, oh, you're off by 0.568. In this case, it says my approximation is higher than the actual value. So the negative sign can get kind of wonky here. But the error is the difference between the two. So I'm going to put an absolute value around it and say it's 0.5, about 0.568-ish. That's about how far off we are. So not bad, not great. It depends on what you're doing with how big of an error you're willing to allow. Okay, for number 4, same idea. The average rate of change is going to be r of 7 pi over 6 minus r of 2 pi over 3. And that's over 7 pi over 6 minus 2 pi over 3. So sometimes I like to find these values off to the side so my work's not so cluttered. So if I plug in 7 pi over 6, I get 3 minus 4 times cosine of pi over 6 is radical 3 over 2, and it's negative because you're in quadrant 3. So that's 3 plus 2 radical 3. We'll just leave it exact like that. And then r of 2 pi over 3 is 3 minus 4 times cosine of 2 pi over 3 is negative 1/2. So 3 plus 2 is 5. And then when we subtract these fractions, let's change 4 pi over 3 so that it's over 6. So, or 2 pi over 3 so that it's over 6. So 4 pi over 6. All right, so r of 7 pi over 6 was 3 plus 2 radical 3. We're subtracting 5 from that. And when we subtract in our denominator, we get 3 pi over 6, which is pi over 2. Combine what you can, negative 2 plus 2 radical 3. Instead of dividing by pi over 2, let's say times 2 over pi. So negative 4 plus 4 radical 3 all over pi. That's the average rate of change. 9 pi over 8, to approximate that, we're going to say it's r of your first point, 2 pi over 3. You could use the other point, but I think it's just good habit to get into the first one. Plus average rate of change times the difference between your approximation value and your jumping off point. R of 2 pi over 3 was 5. We can do this math in here, although actually nothing's going to cancel all that nicely. The pi's will cancel. So I'm just going to put this in my calculator at this point. I'll leave my answer exact, but to find the error, I'll put this in my calculator. All right, so the pi is canceled, so I've got negative 4 plus 4 radical 3 is in parentheses, around 9/8 minus 2/3. We could do that math, but just to save time here, I'm cutting it close. So what about the error? So let's see what that comes out to. So that's 5 plus the quantity negative 4 plus 4 radical 3. Multiply that by 9/8 minus 2/3. So this is our proposed value. And then what is 3 minus 4 cosine of 9 pi over 8. Oh, not too far off, 6.695. Okay, and if we subtract those, that one minus that one, we get an error, depending on your order of subtraction, of about 0.353. In calculus, we'll be looking at things like, well, how do we get the error to be 0.001 or something really small? So something to look forward to. Okay, last idea. A polar function is given by this equation. As theta increases on the interval 0 to pi over 3, what can be determined about the behavior of the graph? So behavior means is r increasing or decreasing? Is the graph getting closer to the origin or farther from the origin? Justify your answer. So the justify the answer is going to be the signs matching thing. So is r increasing in positive? Is r decreasing in positive, etc.? So make a table for theta and r. Plug in all the values between 0 and pi over 3. There aren't that many. So we're going to plug in 0, pi over 6, pi over 4, pi over 3. So when we plug in 0, we get negative 2 plus 2 times 0, so negative 2. When we plug in pi over 6, we, we get negative 2 plus 1. Pi over 4 is negative 2 plus radical 2. Now remember, radical 2 is 1 point something. So this is going to be negative 0 point something. So we're getting closer to 0. And then negative pi over 3 is going to be negative 2 plus radical 3, which is still going to be negative 0 point something, closer to 0. So remember, with negative numbers, if you're getting closer to 0, r is increasing. Okay, what else do we know about r? R is less than 0 for all of these. So that means that the graph is getting, these two things do not agree, right? Increasing means kind of positive direction, less than 0 means negative. The graph is getting closer to 0, 0 because r is increasing and r is less than 0. When those two signs negate, it's kind of like you're moving forward, but you're putting on the brakes, so you're slowing down to 0. All right, a polar function is determined by this. As theta increases on this interval, what can be determined? So make another table. So we're going from pi over 2 to pi. So that's pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi. I plug in pi over 2, I get 3 plus 2 times 0, so negative 3. Then negative 3 plus 2 times radical 3 over 2 negative. No, wait, that's wrong. Sorry. Cosine of 2 pi over 3 is negative 1/2. So that's negative 3 minus 1. Then negative 3 plus 2 times negative radical 2 over 2. That's negative 3 minus radical 2. So this is negative 4 point something. Negative 3 plus 2 times negative radical 3 over 2. That's negative 3 minus radical 3. Again, negative 4 point something. And then pi negative 3 plus 2 times negative 1. It's negative 5. That's actually a minimum value, too. This is the lowest this r could come out to. So in this case, r is decreasing, and r is negative for all of these values. So that means, therefore, these three little dots mean therefore, the graph is getting farther from 0, 0 because r is less than 0 and r is decreasing. When the signs match, decreasing, I think negative is obviously negative. It's sort of like you're going backward and accelerating in the negative direction. So you're shooting farther from 0, 0. All right, that finishes this video. Come into office hours if you need help or have questions.